1. All right, let's recap. So, when we covered 6i at the time, the two key things I wanted you to understand was that every coordinate on the circle, which is called a unit circle means has a length of 1. So 1, 1, 1 on an xy axis. Okay? Now, if this is a length of 1, meaning it's a radius of 1, so you've got a radius of 1, then one of the things we know is that that coordinate exactly at this spot must be what? What's the coordinates right here? 1, 0. Very good. Okay, so that point exactly right there is 1, 0. Then what's the point exactly there? 0, 1. Okay, good. So this is 0, 1. What's the point exactly over here? Negative 1, 0. Very good. And then last spot. So you got 1, 2, 3, and then a 4. This one must be 0, negative 1. Okay, very good. Now, these are the 4 key points, but you can still have coordinates in between each quadrant. Reminder, this is called quadrant 1, so Q1, and we count anti-clockwise, so this is quadrant 2, quadrant 3, quadrant 4. So you've got 4 pieces. Now this point in quadrant 1, sorry Nishi? Yeah. And notes. Yeah. Did you guys get notes? Yeah. 3 A4, not A3. 3 A4 double-sided. So, the point here on the circle, it's always about the circle. This random point that I've picked would have had made an angle of theta, and so I had to rotate it by a certain angle, and it hits this point on the circle, and at this point on the circle, it's an xy coordinate. Now this xy coordinate, as a reminder, remember, if you then looked at the x value is actually just how far this point from the origin to this point is. That's x. True, because that had to be the x coordinate to reach that point. So this has to be the length of x. True, because at this point that's x, and then at this point on the y-axis, this must then be y. Okay, so this is y. So what that implies is that means this height of this right angled triangle that you're seeing here, that's your y height, that's your x length. And what I tried to then show you in a right angled triangle, we were able to prove that the x and the y coordinate can actually be rewritten as something else. Now reminder, what was the hypotenuse equal to again? What's it equal to? Y. Why is it equal to 1? Because it's the radius. It's from this point to that point, it must be the radius of a circle. We said the radius is 1. It's a unit circle. So that means from here to there must also be 1. So once we've got the hypotenuse is 1, we can then look at these sides and we say, well, this is actually the opposite side. This is the adjacent side. Now you've got a hypotenuse equals to 1, but when you write out your trigonometric ratios, sine of the angle, remember, I don't know what that angle is, but whatever the angle is, sine of that angle is equal to opposite divided by hypotenuse. But conveniently, opposite is y, and hypotenuse is 1, which works out to be that y divided by 1 is just y. So that means every time you type on your calculator sine of theta, it will give you the y coordinate in the circle. And theta is the angle. So if it's sine of 30 degrees, that will tell me the y, which is the height, the y coordinate when you make 30 degrees. If I did a sine of 150 degrees, 150 degrees is about over here, then wherever 150 degrees leads me to, so let's say this is 150, then I know at this point, when I type in sine of 150 degrees, it will tell me that y value. So at this coordinate, that's what sine of 150 means on your calculator. So far, so good? Okay, so last session, what I got you to understand was if you followed these trigs, you would have figured out two things. Sine of theta will equal to y, so y equals to sine of the angle. So every time you type sine of the angle, it gives you the y coordinate. And every time you type cos of the angle, so I'll do it again, so over here, cos of the angle, which is equal to adjacent divided by hypotenuse, which is actually x divided by 1, x will equal to cos of theta. So every time you type cos of theta on your calculator, what you're also working out is the x coordinate. Okay, so if I did cos of 150, it only tells me where the x coordinate is on the Cartesian plane. That's what it represents. So that's one of the first key things I was trying to teach last session. Yeah? There was also an acronym I tried to teach you, which you guys came up with your own. So there's ASTC, all student teachers cool, or all science teachers, all scientists test as chemicals. Awesome Silly Train Club as well. Okay, so ASTC. Now, what do those letters represent? You can memorize it, but for me, I actually just look at the x and the y coordinates in each quadrant. You see, if I actually drew it again, I drew another circle just to remind you what we covered. In quadrant 1, if I just solely looked at this point, or any point, what I can already tell is that the x coordinate is in the positive region. That coordinate there is in the positive region for the x values, and it's also in the positive region for the y values. So on your y-axis, whatever this y value is, I know that's going to be a positive. So this is positive, and the x values, clearly, that's going to be on the positive x-axis. So this is positive. But we also know tan, so cos represents x, cos of theta represents x, we know that's going to be positive. Sine represents the y values, we also know it's positive. And then tan, now anyone remember what tan theta was equal to? Sine over cos, because it's opposite over adjacent, and opposite over adjacent is just y divided by x. Because if you drew the triangle, this is your opposite, adjacent, so y divided by x. But y divided by x, that's positive divided by positive. So you end up with positive. The reason why this is called the A region, because it stands for all positive. So all the trigonometric ratios are positive. Or if you look at this point now, you don't even have to memorize that. You can just kind of look at the xy coordinates. So if you look at it, x coordinate, y coordinate, and then y divided by x. Let's figure it out. Over here, is the x going to be positive or negative? Negative, because clearly it's on the left side of the Cartesian plane, so that must be the negative side. So x is going to be negative. But then what about the y values? Is this positive or negative? Positive. So if I then use tan, which is y divided by x, it's just positive divided by negative will give me negative, which so happens that means only y is going to be positive in this region, meaning only the y values or only sine. That's why we call this the S region. So A, for all of them, it's going to be positive. Only sine is going to be positive. And why do we remember tan and cos being positive? Well, this one makes sense. Over here, x will be negative, y will be negative, but if you did y divided by x, negative over negative, positive. That's why tan's the only one that's positive. Over in this region, if you picked a point, you can tell that the x coordinate is positive. It's on this region. But the y values is below the x-axis. So that must be, it must correspond to a y value that's negative. So y is negative, and so if I asked you what tan is, which is y divided by x, positive over negative is negative, and hence cos is always going to be positive. Okay? That's where I left off from our last session. And so if I zoom out, this is what I wanted you to understand. ASTC, what x and y actually represents, So x represents cos, y represents sine, and what was tan? Tan was the gradient, or y over x. So far, so good? Okay, so that's a reminder of 6i. We're going to jump back to 6i right after I teach you some exact values. So some of you asked me previously when you said sine of 30 and I told you it was half, and you're like, how did you know? Or sine of 60 degrees and I knew it was root 3 on 2. This is a chart that we call the exact values chart. Now these are the special angles, 0, 30, 45, 60, 90 degrees. Those are your special angles that you have to memorize. Okay, but in your exam, I've actually put this in your formula sheet. Okay, so you don't have to memorize it, but you need to know how to read it.
So there will be a formula sheet on our exam?
Yeah.
Okay.
I'll show you what it looks like later. Yeah, I've given you all the formulas you need. It's just you got to problem solve. That's all. All right, so what's all these special angles? Where do these numbers come from? It actually just comes from an equilateral triangle and an isosceles triangle. This is the logic. In an equilateral triangle, which I remember one of you or some of you were doing the extension questions, and it came to something like this, where how do you break this apart and look at your sine and cosines? Remember, trigonometry only works for right angle triangles. So here, in an equilateral triangle with a length of 2 by 2 by 2, we also know that the angles in an equilateral triangle must all be 60, because they all have to add up to 180, but they all have to be equal angles. 60 is the only way, right? Now this is special because if I cut this equilateral triangle in half, I will get my 90 degrees on both sides. So I got two right angles. That means this length of 2 now cuts down to become 1 and 1. Now let's focus on just one of the right angle triangles here. If this is 90 degrees, that's 60, then what should this one be up here? 30. And that means this is also 30. Okay? Now that's where your special angles 30, 60, 90 comes from, 30, 60, 90. If I asked you, what is sine of this angle, so let's just call this theta now, right? Sine of this angle would be whatever this height is, opposite, so that's your opposite side, over your hypotenuse. Now we can actually work out the opposite side. How do we do that? Very good, Pythag. So this is 2, this is 1. If you want to work out this side, this would just be square of 2. So remember Pythagoras theorem, c squared equals a squared plus b squared. So you got 2 squared is equal to 1 squared plus b squared. That gives you 4 equals 1 plus something squared. Take away 1 on both sides, and you get 3 equals b squared. So therefore, b must equal to? Very good. So now if I asked you, what is sine of theta? If this was theta, meaning if this was the angle theta, you would say it's opposite over hypotenuse. So opposite over hypotenuse. In this case, if I put it back in again, I said 60 degrees here. This is where sine of 60 degrees, just following opposite over hypotenuse, would be root 3 over 2. So if I go back here, that is why sine 60 degrees is root 3 on 2. Okay, so this chart will work out everything to do with 30 degrees, 60 degrees, and you can do the same thing. So if I said, what's sine of 30? That's opposite over hypotenuse. So sine of 30 would be 1 over 2. That's why I know it's half. Okay? I'm just going to do this again. A over h. Tan theta is opposite over adjacent. So if you followed that for this triangle, so 60 and 30, you would be able to get all the 60 columns. So everything to do with 30 degrees, sine and cosine and tan, you can figure out all of those values just from that equilateral triangle. Okay, so 60s and 30s, 60s, 30s are sorted. 90s you don't need to know, because 90 degrees you've already figured out from the 4 key points, because cos represents the x values. So cos of 90 degrees would be 0. Sine of 90 degrees would be 1. Yeah, because sine is the y values and cos is the x values. So if I asked you what is cos of 90 or what's sine of 90, you can kind of figure it out by looking at unit circle. Yeah? Now, what about the 45 degrees? So we're missing the 45 degrees part. Well, in an isosceles triangle, if I took a unit 1 and a unit of 1, and I knew this was a 45 degrees, this is 90, well then this must be 45 degrees as well, being an isosceles triangle. And by the same thing again, we can use Pythagoras' theorem to figure out what the hypotenuse is. What's the hypotenuse? Root 2. Okay, so therefore, if I said, what is sine of 45 degrees? That's opposite over hypotenuse. Let's say I take this 45, I take this 45 degrees here, then opposite is over here. So it's 1 over root 2. The answer is 1 over root 2. But you guys learned how to rationalize denominator as well. How do you rationalize denominator again? Times by root 2, times the top by root 2. Now 1 times root 2 is just root 2. And then root 2 times root 2 is root of 4. And root of 4 is 2. That's also an acceptable answer as well. Okay, so sometimes in your textbooks you'll find that they'll write it as root 2 on 2 instead of 1 on root 2. But same thing. Okay? So in exercise 6K, what is it about? It's actually you need to memorize this. Now there is a way that you can memorize. You can either keep drawing these triangles. So some students prefer to draw isosceles triangles and equilateral triangles and figure it out themselves. That's fine. I do have another method, which on the next page I'm going to show you how to memorize. Okay? Flip over. It's called the hand method. All right. It might help you if on your hands, if you either draw or you visualize it, or you look on the board and you keep it there. But I used to get my students to draw it on their hands. So if you're a righty, draw it on your left. If you're a lefty, draw it on your right. Okay? Doesn't matter how you draw it, but from left to right, it should increase in degrees. Now, I know I'm writing it in terms of radians because my students, I usually train them to be more familiar with radians. For you guys, you can train it with degrees, but it works as 0, 30, 60, 45, 60, 90. Sorry? You can write both if you want. Yeah. So, 0, 30, 45, 60, 90. This is how it works. In the palm of your hand, there's a formula. It's the root of whatever the number of fingers are divided by 2. Okay? Now this is how it works. Notice that on one side I've got sine and on the other side I've got cos. So anything on the left side is going to be sine. Anything on the right is going to be cos. Now how does this work? Say I want to do cos of 45 degrees. All right? Which finger at the moment represents 45 degrees?
Oh, this one.
Drop it down. So the middle one you drop down so it actually looks like, here's your thumb, here's your second. You drop this one down to, okay? So 45 fingers down. Then you ask, well, I'm looking for cos. Cos is on the right, sine is on the left. So cos is on the right. So how many fingers do I have on the right? I've got 1, 2. So in the formula, it would be then root of 2 over 2.
Wait, what? How do you get that?
I'm following the formula. So square root of the number of fingers divided by 2. Yeah? So if you've got 2 fingers for cos, then it's root of the number of fingers divided by 2.
What's the pi stuff?
That's in radians. So do you remember how I showed you 2 pi equals 360 degrees? So with that property, you can convert degrees to radians and radians to degrees. So 30 degrees is equal to pi and 6. Yeah.
Oh.
As long as you know which finger to use. Because at the year 10 level, we're only working in degrees at the moment. But you guys can work in radians if you're more savvy. Okay? All right, let's try another one. Let's do sine of 30 degrees. Sine of 30 degrees. So which finger is that? Okay, it's your index finger. Okay, so index finger goes down. So here's my thumb. That's one's down. 3, 2, 1. Now sine is on the left, so it's got 1 finger. So root of 1 divided by 2 gives you
1/2.
1/2. So sine of 30 degrees should be half. Can you see that? So drop down your index finger. So I'm dropping down my index finger. And sine is the number of fingers on the left. So I got 1. So the formula is square root of the number of fingers divided by 2. So root of 1/2 gives you half. Let's do another one. What's cos of 60 degrees? So think about which one's your 60-degree finger? That's your ring finger. That's your ring finger. So it should be 1, 2, 3. Your ring finger goes down. So cos, how many cos fingers do you have? 1. So it should be root of 1/2. So the answer is half. Okay? Now, the formula I just gave to you should be able to work out half or 2/3 of this table. So that formula will allow you to do sine and cosine. Okay, so with that you've memorized, that's 15 there, so you memorized 10 out of 15, right? Same thing with the 90 degrees. If you're unsure, sine of 90 degrees, which one's your 90-degree finger again?
Last one.
The pinky. So drop down the pinky. Drop down the pinky. So 1, 2, 3, 4. Drop down the pinky. So I've got 4 fingers on the sine. So it's root of 4/2. And that gives me 2/2. It's 1. Yeah? And if you did cos of 90, what would cos of 90 be? How many fingers if I drop down the pinky? 0, because I have no fingers on the cos for the cos sign. Yes, this only assumes that you have 5 fingers, by the way. It works if you have 5 fingers. All right, so we can now say we got the first 10 out of 15. The second formula is the one I made. If you went to YouTube, they should be able to teach you this bit. This one I made up, okay, but it works. So, same idea, everything's the same. Now, how do you remember this formula? Tan of an angle is sine over cosine, right? The formula still does the same thing. It is the root of number of sine fingers divided by number of cos fingers. Okay, so if you try it now. So let's do tan of 60 degrees as an example. So 60 degrees, which finger is it? No. Yes, ring finger. So this one goes down. Now if I'm saying tan is the number of sine divided by number of cos. Sine is on the left side, so 3 over number of cos fingers, 1. Can you see that? So if I drop this one down, sine fingers, cos fingers. So it should be sine divided by cos equals root 3. Because 3 divided by 1 is 3, is root 3. Let's try another one. Tan of 30 degrees. What's tan of 30? Drop down the index finger. Good, that's 30 degrees. Now how many sine fingers do you have? 1. How many cos fingers do you have? 3. So that means you square root 1 on 3. Now, out of those 2, there is a number that you can square root. 1. What's root of 1? Okay? So you can split it up by doing root of 1 over root of 3. Root of 1 is 1. So you can see what I did there. Sine fingers divided by cos, but when you square root, you can square root the top and you can square root the bottom individually. Root of 3 we don't know, but root of 1 we do know. That's why it's 1 on root 3. So, there is one part that you've got to be careful. Tan of 90 degrees. Now, 90 degrees is your pinky. So what's the number of sine fingers? 4. What's the number of cos fingers? Okay, and what's the problem? It's undefined. A lot of students think it is 0. It is not 0. You cannot do 4 divide 0. You can do it the other way around. You do 0 divide 4, but you cannot divide anything by 0. So that, if you type on your calculator, should be undefined. Okay? Otherwise, if you use the unit circle, it would have been pretty obvious with a unit circle that a 90-degree point, that's a vertical gradient. So obviously it's undefined. Okay, so tan is the gradient of that radius line. That's another way to sort of see it if you visualize it. Okay? So far so good? Okay, so there's two ways to memorize this. You can either memorize it through the triangles, equilateral triangle versus isosceles, or the hand method. Okay? Either one. But it allows you to memorize the exact values. All right. All right, team. Here we go. So, exercise 6I, what we had left off with, you had the basics, you understood what x coordinate and the y coordinate represents. Now, what they want is, everything I gave to you so far, 0, 30, 60, 45, 60, 90, is only in the first quadrant. And the reason for that is because when you draw a circle, that first quadrant, no matter which the coordinate is, whatever the x, y coordinate is, you end up with a right angle triangle. Okay? That right angle triangle can be repeated in all the other quadrants because we're taking the same shape. Because all we're interested in is the x length and the y height. Now there's only a maximum of 1 for the x values and there's a maximum of 1 for the y values. So it actually doesn't matter what the angle ends up being. The angle can keep changing, but the x and y's actually repeat itself as you go around the circle. This is why we only need the first quadrant angles to know. Okay, that's why you need to memorize the exact values. Now, let's go back to your understanding again. I'm going to draw a triangle. Let's say I made 30 degrees. Angle of 30 degrees. Let's test your understanding and memory again. What is sine of 30 degrees?
Root 2 over 2. 3 over 2.
Sine is on this side. Cos is over there. Root of 1 over 2, which is 1 over 2. So I said sine of 30 degrees. Root of 1 over 2 is half. So now you know the y value. Remember, the y value represents sine. So when you do sine of 30 degrees, we know it's half. What that means is, that's half right there. That's how you get a height of half for the triangle. This height has a height of half, right? Because that's what sine 30 degrees is. But what's interesting is, you don't have to do sine of 30 to get half. You can do multiple angles here. If you think about it, to get a height of half, I can draw the same triangle to get the same height in quadrant 2. So if I drew the same triangle, where it has exactly the same height, so this is also half, and the radius is still 1, so they're both symmetrical, then this angle here would also be 30 degrees. Agreed? So that triangle, this triangle, exactly the same. That's how I'm going to get a height of half. So that means this coordinate over here has a height of half. But what would the angle have to be if I was starting zeros here and I'm rotating all the way to this point? What would the angle have to be? 150. So, can you see from here to here has to be 150 since this is 30. 150 plus 30 gives you 180 degrees, which is half a circle. And that's special because that means I can also get an answer of half in this region when I do sine of 150. Now this is really special because when we talked about ASTC, we know that as long as you're in quadrant 1 and quadrant 2, sine will always be positive. Yes, I can get 150 here, but actually if I think about it, that was 180 for one turn. Another 180 makes it 360, but if I add another 180, 540. Now, let's just think for a moment here. If the 540 is exactly the same spot this is also 540 degrees. To get to that point, I had to do 1, 2, 3. That's 1.5 revolutions, right? To get here. But if I went from 540 and then went back by 30 degrees, what would angle would that be? 510. So that means I can still get the same triangle at 540, which is here, and I went back by 30 degrees. I should still get the same height. So 540 less 30 degrees would still give me the same triangle, hence 510. Sine of 510 should also give me half. This is what we call by a reference angle, because as soon as you got the 30, you can go as many times as you want and work out what the angle can be. So what happens when I type on a calculator? So if we try it now. So you guys just figured out logically, sine of 30, we know it's half. We then tried sine of 150, which you told me was also half. But then sine of 510 is also half. Do you see that? So, but that's not the only spot too. Remember, there's 2 quadrants. Quadrant 1, quadrant 2. So remember, if I went all the way here, so I go 1, this is 180 degrees, and I went all the way back here, that's 360 degrees. Now, if this is 360 here, and to get that triangle, which is 30 degrees here, I just need to add 360 by 30. And that should give me another angle. Now, 360 plus 30 gives me 390. So technically, if I then type sine of 390, I should also get. Does that make sense? Okay, so the y value stayed the same. The angles change. Now, this is one of the reasons why we don't like working in degrees, is because if I ask you what sine of 5,120 is, it's hard to figure out how many revolutions you have to go. Whereas in radians, it's more special, is because you know exactly where you're starting. That's why we like radians, yeah? But at your level at this moment, you're probably going to work up to about 540 degrees or so, okay? But at least you know how to move around the circle. That's the skill. So that's what we're going to practice today, is to work around the circle using the reference triangle, using the first triangle, no matter what that angle is. It's 0, 60, 30, 90, or whatever it is. We're using the first quadrant to figure out the rest. Now, the signs only matter if you're doing sine down here in third quadrant. We know sine is going to be negative. The sine is the y values. So the y value is going to be negative. So those are the only times you have to be careful. That's why people memorize A, S, T, C. Okay? Let's do another example. Okay? So that's what I'm trying to sort of teach you, is part of your exercise 6I. It's to understand that. Over time, you don't need the picture, but to start off with, I think the picture will help you understand. Okay? All right, let's have a look at, what was I doing this one? Let's practice with a question so you get more practice, okay? Here we go. Sine 40 degrees. Now, the question asks you to, actually we just did sine, let's do cos, just so you can get a feel of all the other different ones. Let's do cos of 74 degrees. Now, I don't know what cos of 74 is, because it's not an exact value. Right? So, write this as part of your notes. Let's do cos of 74. We want to figure out what's another angle, if I did cos of another angle, to give me exactly the same answer as cos of 74, right? So, now they want you to do it in quadrant 2, right? But we're going to practice in multiple quadrants here. So let's have a look. Let's draw a circle. Here's your unit circle. Now, 74 degrees, we're going to draw a triangle to match that in quadrant 1. So here we go. 74 degrees could be maybe like that. That's 74 degrees there. Gives me this point. I've got an x and a y coordinate. So that tells me this is my right angle triangle. Cos, which one does it represent? X or the y coordinates? X. So cos represents the x. And the x is on the x-axis, right? So this is the length that I'm looking at. So whatever cos of 74 is, that's telling me that length. Now I want the exact same length in a different quadrant. I want the exact same length. I want that same length here, whatever this x coordinate is, I want it in quadrant 2. Now, if I want it in quadrant 2, this is quadrant 2, that means this has to be x. But in order for me to have x here, I have to draw exactly the same triangle. That means I need 74 degrees up this way. True, so I'm going to draw it again. Here we go, 74 degrees this way. 74, and I should get that same identical triangle. Okay, so I've got 74 this way, 74 that way. So from the x-axis, I moved up 74. From the x-axis, I moved up 74. That gives me the same x length, same y values. However, there is a difference in sign. See, over here, x is positive, but over here, x is negative. So, let's work out the angle first, though. If this is 0, what would the angle be to go from here to here? Remember, this is 74 degrees. How much more do I need to make that 180? 106. So what I know is, when I do cos of 106 degrees, that's an obtuse angle, but what I definitely know is the answer is going to be a negative answer, but I just don't know what the value is. That's where your calculator does the ratios. Okay, your calculator will do the ratios, and here is what we know. So we know that when we say cos of what angle, when we're asking cos of what angle, that will give you the same thing in quadrant 2, it has to be 106. And watch, I can do this now, even though I don't know what cos of 74 is, I do know if I do cos of 74, which, whoops, is 0.2756, right? But if I do now cos of what was it again? 106, I should get the negative of that. It'll be the negative. But the question, notice why I put a negative. Whoops, let me go back again. Notice why in my answer I had a negative here. Because I knew cos of 74 would have given me a positive answer. This was 0.275, right? And I know that if I did cos of 106 degrees, it would have gave me a negative 0.275. So the only way to combat that negative, to make sure they're both positive, to be equivalent, I had to put another negative at the front. Because cos of 106 degrees, which is in quadrant 2, that will give me a negative value. So to combat that, I have to put a negative at the front. So in your lesson so far, what they're practicing you to do is to move around the quadrants. You don't have to stick to quadrant 1. You use it as a point, and you draw it in either quadrant 3, quadrant 4, and you just keep moving around the circle. That's a lot to take in. That's really hard for my year 11s to normally pick up. You guys pick up much faster than them, so it might take 2 sessions. So today's 1 session. You get to revise again next week. You've got the long weekend to think about it. That's what I'm giving you time to think about. All right? Hands up, you like me to do one more example, or you're happy? Yeah, good? All right, I'm going to pause there. That's pretty much the skill you want to practice. So if you go back to 6I, that's what the questions are asking. They're trying to get you to work within the different quadrants. And you got to figure out what the angle is. So when they say obtuse, they mean quadrant 2. Obtuse is bigger than 90 and less than 180. Okay? All right, Tim, I'm going to stop the